Some series to integral calculus. Some series to integral calculus, the arena in which we are pursuing the discussion. Some series to integral calculus. Can we calculate summation of series through integral calculus? Mind blowing, amazing. And we took example of arithmetic series, that is 4, 9, 14, 19, 24, 29. Everywhere we are adding it by 5. Everywhere we are adding it by 5. It is a normal arithmetic series. Normal. I remember the solution was 5n square plus 3n by 2. This is what I remember. If someone wants to add 4, 9, means there is a series 4, 9, 14, 19, 24, 29, 34, and so on. Gap is 5. Gap is 5. Or if someone think about a multiple of 4, then first is 4, then next is 9. 4 into 2 plus 1. Third is 4 into 3 plus 2. Next is 4 into 4 plus 4. 4 into 4 into 1 plus 0. 4 into 2 plus 1. 4 into 3 plus 2. 4 into 4 plus 3, 19. 4 into 4 into 5 plus 4, and so on. This is a arithmetic series. Arithmetic series means the next number will be constantly added, and geometric series is next number is constantly multiplied. Makes sense? Geometric series. Like if I start with a number called alpha, then next will be a into alpha. Next will be a square into alpha. Next will be a to the power 3 into alpha. Because we have to multiply a everywhere. This is called geometric series. Whereas arithmetic series, I have to if I have alpha at the beginning, next will be a plus alpha. Next will be 2a plus alpha. Next will be 2 3a plus alpha. Means I have to keep adding the a every. I'm sorry. First is alpha. Next is a. Next is a plus, yeah. Next is a plus alpha, and then next is a plus alpha, in that manner, something like that. So one is addition and one is multiplication. Geometric series and arithmetic series. We have successfully solved this arithmetic series, that is 4, 9, 14, 19, 24, 29, and so on. If that is true, then what about arithmetic? What about, now someone would say, up. I would have done in something else, some other way I would have done it. What else you would have done it? Anyone would ask. Let's try. Even I have not tried. First time I was thinking. S equal to 5, 9, 14, 19. Okay, this is S. This is S. Okay, in that manner, if I tilt it, if I invert it, then it becomes S equal to 19, 14, 9, and 4. If I add all these terms, then it becomes 2S. This side it becomes 2S, and this side it becomes 19 plus 4, that is 23, and then 14 plus 9, 23, and then 9 plus 9, 4, 9, 14, and here 19, 14, 9. 14 plus 9, 23, again 23, and last term will be 19 plus 4. All are 23 only. S equal to 23 by 2. 20. S equal to 23 into 4 by 3. Means if there are 4 terms, if there are n terms, n into n into what is the summation of the last number and the first number? I believe it is. Anyone would say in that manner. We calculated 5n square plus 3n by 2. This is what I remember. 5n square plus 3n by 2. If I take out, it becomes n in bracket. Okay, first let me try. N equal to 3, then it is n equal to 2, then 4, 5, 4, 20 plus 12. n equal to 2, 6, 26 by 2, 30, 9 plus 4, 30. If I take n to the power, means I'm trying to, if people can watch our previous video, summation of 4, 9, 14, 19, 24, 29, and so on. If there are n terms, then it came as 5n square plus 3n by 2. If I take n as 3, then it becomes 3 in 3n square. It will come as 9. 9 into 5 will come as 45. And then 3 into 2, it will come as 6. It will come as 51. Oh, this is not what we want. N square is 3 into 3, 9 into 5, 45. And then we have 3 into n. 3 into 3 will become 9. 54 by 2, 27. It should come 27. 4 plus 9 plus 14 should come 20. Yeah, it is 27. Anyway, but if someone does the computation directly, then 2s equal to 2s equal to first term and their last term. You add it into how many terms are there? N. I think so. Into n. That's it. By 2. Okay, if I do through our computation, n I can take outside and it becomes 5n plus 3. N outside 5n plus 3 by 2. This proves that 5n plus 3 is nothing but summation of first item and last item. 5n plus 3. Okay, anyway, but this is very nice. What we did is very nice. N into 5n plus 3. Rather than saying you take first term and last term and add it, 5n plus 3 and whole by 2. Okay, but anyway, someone can find it. There is not a big deal here or something like that. Okay, let's try square. How much square will come? Square means first term whole square, second term whole square, third term whole square, and so on. If I had a summation of 5, 4, 9, 30, 4, 9, 14, 19, 24, 29, and so on. What about summation of every item's square? That is 4 square, 9 square, 4 square, 9 square, 14 square, 19 square, 24 square, 29 square, and so on. If I take only two terms, 4 square and 9 square, okay, then 4 square is 16 and 9 square is 81. Okay, if I reverse it and add it, probably they will come as, let's try simple example. Let's try start with 4 and make 2 gap. Then or start with 1 and make 1 gap. Both are similar. 1, 2, 3, 4. Take a square now. 1 square, 2 square, 3 square, 4 square. Then it will become 1, 4, 9 and 16. 1, 4, 9 and 16. If I reverse it, will it be same? 16 plus 1, if I rotate it, 16 plus 1 is 17. Next is 2. 2 comes a square is 4. And this side we have 3 square 9. If I rotate it, 9 plus 4 is not 17. So someone's mind will not work. I am sure about it. 1, 2, 3, 4 where gap is 1. The way earlier gap was 5. Here gap is 1. 1, 2, 3, 4. Someone would say S equal to 1, 2, 3, 4. Yeah. S equal to 4, 3, 2, 1. Yes. Now add it. It becomes 1, 2, 3. It will become 5 plus 5 plus 5 plus 5 4 times. 2S equal to 5 plus 5 plus 5 plus 5 4 times. Then S equal to or addition by 2. If I say, can you compute 1 square, 2 square, 3 square, and 4 square? He would try to do the same thing. Now he would invert it. 4 square, 3 square, 2 square, 1 square. 1 square, 4 square, it will come as 17. Then 2 square, 3 square. 2 square is 4 and 3 square is 9. That will come as 13. Then 3 square and this side 2 square. Again it will come as 13 and then 4 square and 1 square. That will come as 17. Not same. If I take up to 5, that 25 and 1, it will come as 26. Next is 2 square, that is 4, and this side it will come as 4 square. 16 plus 4 is 20, not same. So no one can say you take s and then again s and invert it and add it. It will not work. So can I take example now? We had initial problem as 5, 9, 14, 19, 24, 29 and so on. What is the summation of a square now? 4 square, 9 square, 14 square, 19 square, 24 square, 29 square, 34 square, up to n term. Can someone compute it? This is a question that would hit it. Now, the plain way of calculating the algebra, consider this as s and invert it and another s and then add it and then that will not work. Then someone has to remember some other way. That is the problem, and we are addressing that problem only. What we are addressing? We are addressing that problem only. Means how we can find any summation series through a same way, single way. Not okay, if it is 1 plus 2 plus 3, then this way. If it is 1 square plus 2 square plus 3 square, then this way. If it is 1 by 2 plus 1 by 3 plus 1 by 4, then this way. If it is 1 by 2 plus 2 by 3 plus 3 by 4 plus 4 by 5, then this way. How many ways someone will remember? Use integral calculus. That is the straightforward way. One way we will talk. Anyway, many times we have demonstrated the concept of integral calculus. Okay, many times we have demonstrated the concept of integral calculus, and that concept is integral calculus. Integral calculus falls in area computation. Integral calculus always calculate area one. Okay, I have 3D I have 3D, I have 4D, and I have 2D. Everything calculates area only. No. 3D calculates volume. 3D calculates area only. Only thing is you have to take XY plane as independent component. Not X as independent component, Y is independent component, and Z is dependent upon X and Y. Okay, take X, Y together as independent component. Then if someone integrate function over X and Y, that is Z, dxy, not dx dy, dxy, integrate with dxy, then it will come as function over xy and dxy. It will compute area only. Area in term of xy plane, then you can break again to have the volume. So integral calculus works with two variable only. One is independent variable, one is dependent variable. Okay, so what concept we are taking is, if I try to calculate series summation, then we will bring a concept of independent variable, dependent variable from somewhere. Okay, this is up to the intelligence of someone or experience of someone. How someone can break any problem into independent variable and dependent variable. Then draw a graph, calculate the area, and make that area gives the result what you want. Like in examination, question is written like this: what is 4 square plus 9 square plus 14 square plus 19 square plus 23 square plus 29 square plus 34 square. This is what is written in examination. Now, can you please tell me? Okay, if it is or it is written plus up to 10 terms. Up to 10 terms you have to calculate. Now, if someone or up to 20 terms you have to calculate. If someone takes calculator also, then it is okay. If someone takes calculator, then I believe he can do little quicker. If does not, then he cannot do at all. Or it is up to 100 term. If it written up to 100 term, then no one can do through calculator also. Means full 1 hour will go in calculator only, not first. Okay, then in that manner, what we need now? So in that manner, we need a formula now. Only one formula, and put 20 term or 50 term or 100 term and do the calculation only one time, not do calculation 100 time and then keep adding. No one will do. Okay, in that fashion, now consider this is x-axis. Now we are molding the problem into calculus, into technology of calculus. Okay, if someone say that how long you walk. Okay, how long you walk? I walk around 20 kilometers. Okay, I walk in one go, I can walk up to 20 kilometers. Okay, then someone would say, can you do the same thing through motorcycle? Okay, if motorcycle comes into the picture, then leg of a human will convert into tires because motorcycle runs on tires, not on foot, not on feet, because technology is different. Similarly, if I have to do calculation of 4 square plus 9 square plus 14 square plus 19 square up to 100 terms, that will come as very, very big number. I understand this. 100 terms, then I have to use different technology. And for that technology, the equipment, the resources, the methodologies, everything will be different. So we will use integral calculus. And for integral calculus methodology is one is x-axis and one is y-axis. This is the science of calculus, what we can do. Whenever calculus comes, there will be a x-axis and there will be y-axis. This is called independent component. This is called dependent component. This is independent component. This this is dependent component. If this is x-axis, this is function over x-axis or y-axis. Why it is function over x-axis? Means if I have different point in x, then for each x I have function over x. For each x I have function over x. That will be vertical at that point. If I connect all the vertical, I can draw a graph, and that graph is called function over x graph. If I compute fx dx from x1 to x2, it will give area underneath the graph. What do you mean? Consider this is function over x. What is function over x? At x equal to 1, I have a variable called function over x. Like function over x equal to sine x. Then when x is 1, what is sine x? That is the vertical. When x equal to 2, what is sine x? That is the vertical. So whatever the value comes, x equal to 3, what is the sine x? That is the vertical. If I connect all the vertical points, it will draw a graph. If I say sin x dx from x1 to x2, it will give the area underneath it. This is what integral calculus was. I don't like this kind of thing. I want 4 square plus 9 square plus 14 square plus 19 square up to 100 term, where I will go for x-axis and y-axis and function over x and then x1 to x2 and dx. Why? I don't need those kind of things. Question is very straightforward. If you can't compute, then you can push out. This is what is. What is x and y and function over x and this and that? Boss, we need this. Okay, we need this. We'll try, we can solve through. This is different technology only. So one technology is arithmetic technology. This is what the question is. Another technology is called algebraic technology. And another technology is called calculus technology, which uses algebra. Okay, I have to transform my problem, arithmetic problem, into algebra and then to calculus, so that it will use engine of calculus to solve the problem, and then I have to transform back to the arithmetic. Makes sense? I have to transform it to arithmetic. Like someone has to make flour, like wheat flour, like wheat flour. Now, if someone has to make the wheat flour or flour, F-L-O-U-R, flour or flour, wheat flour, if someone has to make, then he can grind at home only. He can grind or he can crush it repeatedly. Then wheat will become flour. Okay, but no, he wants to use bull for this or ox for this. For ox, there will be some machinery will be there, and ox will be tied to the machinery, and ox will rotate now. Okay, now he will say, I am not going to do these many things. You want wheat to flow, right? Yeah, keep wheat in a closed chamber and crush it. It will become flour. Okay, but you cannot do for 10 quintal, I mean 1 ton, that human cannot do. Then you have to use that setup, and then ox will be tied and ox will rotate, and slowly your wheat will become flour. Okay, we will do. Once it is done, then you can collect it, and it is as good as what you had done. No, no, no. I won't do it through ox. I have seen one machine out there, and machine does then you have to follow their protocol. If you try to take it to machinery, then you have to follow their protocol. If you try to take it to ox based, then you have to follow their protocol. So you have to modify your resources the way that machine wants. Then machine will do the work and then it will give it to you back. Then do whatever you want. Similarly, if I have problem in arithmetic and if I want to get it solved through calculus machinery, then I have to transform into the way machinery wants. Like if I try it to go into ox way, then little bit someone need to pour the wheat in the confined box, okay, and then ox will rotate and then floor will come out. Then you have to put wheat again and then it will rotate and then floor will come out. Then it will do like this, bulk wheat. But if you see the machinery, then first there will be a motor, there will be a machine and something like that. And machine will take the wheat constantly. Okay, someone has to give or through some way, wheat will go very slowly. One, two, three, four, five, six wheat will go in every time. That will keep going there and it will crush and they have their own way. But you have to follow what they want. Then only they will help you. Similarly, calculus has its own way. If you want to solve your problem through calculus, you have to change little bit so that calculus machine will take the problem and then it will solve it and give it to you back. This is what we are doing. Now we have to then we through calculus way we have now x-axis, and in x-axis when x is 1, I have a number called 4 square. When x is 2, I have a number called 9 square. When x is 3, I have a number called 14 square. When x is 4, I have a number called 19 square, and so on. Okay, I have to solve this. Means on x-axis, that is independent component, I have x equal to 1, x equal to 2, x equal to 3, x equal to 4, and so on. The value at x equal to 1, that is also called function over x, is 4 square, 9 square. These are called vertical or function over x. If I connect all the vertical point, top points, it will make a line, and that is called function over x. What is function over x? We have already talked. Function over x is 4x plus x minus 1, that is 5x minus 1. Whole square means 5x minus 1 to the power whole square. What do you mean? When x equal to 3, it is 5x minus 1 whole square. That will become 14 whole square. X equal to 4, then it will become 20 minus 1, 19 whole square. Means function over x is 5x minus 1 complete whole square. That is function over x. Means summation x equal to 1 to n. Summation x equal to 1 to n. Function over x. Function over x plus function over x plus function over x plus function over x. Up to whatever term it is. N term. Where x is 1, x is 2, x is 3. Sigma summation x equal to 1 to n function over x. Okay, means function over x plus function over x plus function over x n times, where x is promoting 1, 1, 1. First function over x is when x equal to 1, x equal to 2, x equal to n. Okay, if I want this addition, then where integral calculus comes into the picture, I have a discrete function, digital function, that is 5x minus 1 to the power whole square. But this is discrete function. This is not a continuous line. It is a combination of some points. Can I think about another line that is a continuous line called gx? Gx is a function that is a completely continuous. And if I have x equal to 1, then I have fx at 4 square. Then x equal to 2, I have fx at 9 square. Between these two, can I take one area strip that will go and hit gx? Means integration x equal to 1 to 2 gx dx will give this area, and this area will be exactly same as fx at x equal to 4. Next will be area between x equal to 2 and 3 will be exactly same as fx at x equal to 2. Left hand side area will be on right hand side. Means when x equal to n, I have fx, this is the original fx, I have fx as at x equal to n is 5n minus 1 to the power 2, that is fx. That will be same as the n to n plus 1 area into gx. This is our invention. It is not available in any of the book. Summation series through integral calculus. Means if I say sigma x equal to 1 to n fx, then that will be same as limit x equal to 1 to 2 gx dx plus 2 to 3 gx dx. Means fx plus fx plus fx plus fx plus fx n time will be same as limit x equal to 1 to 2 gx dx, 2 to 3 gx dx, 3 to 4 gx dx. At the end, n to n plus 2 gx dx. Okay, what do you mean? When it is x equal to x, then fx at x equal to x is equal to limit x equal to x plus 1 gx dx. If that is true, then can I find gx in that manner? If I am able to find gx in that manner, then what we have now? We have area strip, different area strip, and each area strip corresponds to left hand side fx. This area strip corresponds to left hand side fx. This area strip corresponds to left hand side fx. Means there are n number of area strips, like there are n number of verticals. If I add all the area strip, that is same as adding all the vertical, because one area strip corresponds to one vertical in value. Means addition of x equal to 1 to 2 gx dx, 2 to 3 gx dx, n to n plus 1 gx dx. It is same as summation x equal to 1 to n fx. Same. Okay, means net at integration, if there are n number of area strips continuous, non-overlapping, it will come to 1 to n plus 1 gx dx. I have to find gx. Means summation x equal to 1 to n fx is same as integration x equal to 1 to n plus 1 gx dx. If I find the gx, what is gx now? Now gx, now we have fx at x equal to x is 5x minus 1 to the power 2 equal to gx dx from x equal to x plus 1. Okay, now gx dx is fx, then gx is dfx by dx. Okay, dfx by dx will come as x minus 5x minus 1 whole square. Differentiation will come in terms of x only, because dual order will come, differentiation will come to single order. So we will try with simple x. It is a single order, simple x. So simple x, if I try, then x square by 2. Limit is x to x plus 1. It will come as x plus 1 whole square minus x square by 2. That will come as 2x plus 1. 2x plus 1. 2x plus 1 by 2. It will come as x1. This side we have 5x minus 1 whole square. That is 25x square plus 10 plus 1. 5x minus 1 whole square, 25x square minus 10x plus 1. So it is in x square, that is 25, and here we are getting in x1. So if we had started with x, we got in x1. We'll start with x square. Who is stopping us? Let's try with the x square. So we'll try with x square. That will come as x to the power 3 by 3. X to x plus 1, x plus 1 to the power 3 minus x to the power 3. That will come as 3x square plus 3x plus 3x square plus 3x plus 1. X to the power 3, x to the power will go away by 3. That will come as x to the power 3x square by 3, x square. Wanted is 25x. We are getting x square. So we'll try with 25x. So 25x square. 25x square integration will be 25 by 3x to the power 3. X to the power 3 will get settled down as 3x square plus 3x plus 1. Now 25 by 3 will become 25x square. This is what we want. 25x square. Next will become 25x by 3 will go away. 25x. This side we have minus 10x. This side 25x minus 10x. Means I have to subtract with minus 35 to get the same thing. We'll try again. 25x square minus 30x. Minus 30x. We'll start again. 25x square will become 25 into x to the power 3 by 3. That will become 25x square plus 25x plus 25 by 3 into 1. And now we have 30x minus 30 x square by 2 minus 30 by 2 x square, that is x plus 1 whole square minus x square, 2x plus 1, that will come as minus 30x. This side we have up, we have 25x. We made some mistake. Okay, this side we have 25x, and this side we have 30 minus 5. Oh, sorry, I have to take 35 instead. Then it is all right. We'll take 35 now. So if it is 35, this side we are getting 25x. This side we are getting minus 35x. That will come as minus 10. Perfect. So 25x square minus 10, we have got it. Now let's settle down the constant one. The first part constant is 25 by 3. This side constant is minus 35 by 2 plus in there it is 1. So it will come as minus 35 by 2. Minus 35 by 2. Okay, this side we have 25 by 3. 25 by 3 minus 35 by 2, how much it will be? It is a big thing, I believe so. So denominator will be 6, and then it will be multiplied 3 times, 2 times. It will become 50. 25 by 3, 6, it will become 50. 50 minus 35 into 3. 35 into 3, that will become 105. 70 plus 35. So it will become 50 minus 105 by 6. That will become, I believe, minus 55 by 6. Minus 55 by 6, I think so. So we will do the same thing. So minus 55 by 6, then I have to add 55 by 6 to have it go away. I'm sorry. What is the wanted one? Wanted one is 5x minus 1 whole square. 25x square minus 25x square minus 10x plus 1 plus 1. We want 1. We want 1. Whereas here we are getting minus 55 by 6. We want 1 and we are getting minus 55 by 6. Means we have to add something so that it would become 1. What we have to add that it would become 1 is 1 plus 55 by 6. 55 by 6, 55 by 6 will go. 1 plus 55 by 6 we have to add now. Okay, so we will try again. 55 by 6 plus 1 will become how much? 61 by 6. So we will try again. 25x square. 25x square. Hope I keep forgetting. 25x square minus 25x square minus 35x. 35x and then plus 61 by 6. This is how it is. This is successive integral, but in one way only someone would get the result. 25x square minus 35x plus 61 by 6. We'll try again. 25x square will become 25 by 3x to the power 3. X to x plus 1 will get, someone would get 3x square plus 3x plus 1. Outside waiting is 25 by 3. That will become 25x square plus 25x plus 25 by 3. Okay, now 35x. 35 by 2x square. X to x plus 1. X square plus 2x plus 1 minus x square. 2x plus 1. That will become minus 35x minus 35 by 2. Okay, minus 35x plus 25x become minus 10x. Net it will become 25x square minus 10x. This is what we want. But next it is becoming 25 by 3 minus 35 by 2. Makes sense? Last one we have taken 61 by 6. Integration is x plus 1 to x 61 by 6. Now we have 25 by 2, 25 by 3 minus 35 by 2 plus 61 by 6. 6 is the common denominator. It becomes 50. 50 minus 35 into 3, 105 plus 61. Makes sense? Then plus 61. Then we have 50 plus 61 minus 105. Oh, we have made something wrong. Okay, how much it is? Let's see. 61 plus 50. 61 plus 50. 61 plus 50 will become 101. 111 minus 105. 6. 6 by 6, 1. This is what we want. Means we got the gx. Gx is 25x square minus 35x plus 60 plus 61 by 6. If this is the gx, then addition of all the sub area is same as addition of all the vertical. Means summation x equal to 1 to n fx is same as the limit x equal to 1 to n plus 1 gx dx. Same thing. So now we can rewrite as 25x square minus 35x plus 61 by 6 dx. Dx integration from x equal to 1 to n plus 1 will give the result. We'll try now. 25 by 3 x to the power 3 minus 35 x square by 2 plus 61 by 6 x, and then here 1 to n plus 1. If I settle it down, it becomes 25 by 3 n plus 1 to the power 3 minus 1 in bracket n plus 1 to the power 3 minus 1 to come as n to the power 3 plus 3n square plus 3n. That's it. 1 will take away. 25 by 3 in bracket n to the power 3 plus 3n square plus 3n. Okay, that will come as 25 by 3 n to the power 3 plus 25n square plus 25n. That's minus 35 by 2 x square. 35 by 2 n plus 1 whole square minus 1 square. It will come as n square plus 2n. That's it. Then it will come minus 35 by 2 n square minus 35n plus 61 by 6 x n plus 1 minus 1 n. 61 by 6 n. Someone can settle it down. It is looks like it is too big. It is too big. We can try n equal to 2 then. What is the summation? N equal to 2. First is 25 by 3 n plus 1 whole square minus 1. 2 plus 1 to the power 3. 2 plus 1 to the power 3 will become 8. 2 plus 1, 3. 27 minus 1, 26. 25 into 26 by 3. Someone can calculate. Minus 35 by 2. And then n plus 1 whole square minus 1. N is 2. Then it is becoming 2 plus 1, 3 whole square. 9 minus 1, 8. It will become minus 35 by 2 into 8. Minus 35 by 4. Minus 35 into 4. Plus 61 by 6 n. N is 2. N we have taken 2. So 61 by 6 into 2. 61 by 3. Oh, we have this side we have 25 into 26 by 3 plus 61 by 3. So 25 into 26. 25 into 26 plus 61, whatever it comes. Okay, 25 into 26, how much it will come? Okay, it will be a big number, I believe. And then plus 61 by 3. If I take 25 into 26 by 3, it will come around 25 into 9, that is 225. 225 plus 20, it will come around 245. 245. Now this side we have minus 35 by 2 n square plus 2n, or n plus 1 whole 8. 8 minus 35 by 2 8 minus 35 into 4. Minus 35 into 4 will go minus 140, I think. Minus 140. So 245 to 245, I remember. 245 minus 140. It will come around 100. That 100. Okay, we'll try now. 4 square plus 9 square. 81 plus 16. 96. Okay. Looks like it is giving the result. Knowingly, unknowingly, it is giving the result. Anyway, someone can try upon. This is what we'll try with the other way also, or we'll try to take another example. Mind blowing, amazing. This is called finding the summation series through integral calculus. Can someone believe on this? That this would give a perfect result that no one would have expected. Amazing. Okay, this is what that is not available in the book. Please don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.